My name is Jarno Virtanen. I'm from Finland, which is in the east. I think it's that way. It's one of these cloud-native Nordics countries. I'm going to talk about our IDP, our internal developer platform. And since I'm not selling anything, I figured I could be honest with the assessment. First, just to get us on the same page, this is the definition I'm going by. IDP is a built-by platform team to build golden paths and enable developer self-service. We agree with the definition and the idea behind it. But first, we will go back about a year to a completely normal workday of our company. There was no events, no global outages or anything going on. And there was this message to our support channel from a developer, from one of our app teams, that their service had gone down. It didn't respond. We began investigating, and we noticed that they have applied these pending infrastructure as code changes because they had this drift control that noticed the change, and they applied these changes. These changes were from the underlying app module, the sort of golden path app module that we have in our IDP. The change itself looked like this. It was some alb.ingress.kubernetes.io/scheme was changed from internet-facing to internal. Now, you are all platform engineers and you suspect that this is dangerous, and even an app developer might think that. But if you are without a context, if you don't know other things behind this change, and if you are part of the dev team and you are supposed to keep the IAC up to date, then these are effectively forced upon you. And you think that these feel like details you shouldn't need to care about. I'm sure the people who made this change know what they're doing and have tested the changes. Now, earlier there was a pull request for this same app module to this variable internal, which determines if the load balancer will be internal or in the public internet. The default was changed from false to true, meaning that if you didn't provide this value, then it would be internal, which seems like a reasonable change. And turns out that this app in question and dozens of other apps had not set this flag explicitly. And thus, when the pull request was merged and they applied their changes, the load balancer was changed to internal instead of being in the public internet. And then our cloud proxy could not communicate with an internal load balancer, at the time at least. And this meant that the service went down. The fix was easy. Once we figured it out, just give the flag explicitly, false, internal false, and wait for the changes to propagate. My feeling is that with these sort of cases, there's always these two sides thinking it's the other side's fault. The IDP or the ops team, which I'm part of, might think that you, as the developer, you need to understand the changes you apply because you are responsible for your application, for your infrastructure. The app developer might say that they don't understand at least all of the changes they are forced to apply. What I think is that this nicely highlights the problems with our IDP and what we should fix. First, I think the interface, the API we provide for our developers is, well, it's not good, it's bad. It doesn't mean the whole system is bad. I think the whole system is fine, it's good, but the sort of interface, I think, is bad. And I think there's also this unclear division of responsibilities. You could also say that it's the division is wrong. So who am I? I work in the ops team at Yleisradio, which is the Finnish National Broadcasting Company. We operate and produce a couple of TV channels and radio channels, broadcast them in Finland. But as the world is going more digital and in the web, we also have these digital services like yle.fi, which is the news website, and we also have the streaming platform arena.yle.fi, which streams the TV channels and radio channels, and we have on-demand content also. And the size of the sort of this online digital services, the ops team or the IDP team, which I'm part of, is 7 people altogether. And the users of our platform is around maybe 100 people, so the active users. There's more people developing the applications, but maybe that's the size of the platform users. And there's around 200 app instances. Not all of them are like individual applications, but anyhow, that's the size of our operations. So I will first show the good parts quickly. A typical need for a developer is to get their service on the internet, whatever that is. It's a web app or an API or whatever. So I have a pre-recorded demo because I'm a wuss. I want it actually work. So you will hopefully see the demo, the pre-recorded demo. It's in a 1.5 speed, so it's a little bit faster than I usually type. And it doesn't work because I don't have an internet connection, of course. Sorry. Maybe now. No. Nice. Can I reload the page somehow, please? Yes. I'll do it this way. Yes. It's difficult even with pre-recorded demos, it seems. So we have an existing Git repo and an existing ECR repo, and we want to get this thing provisioned to the internet. It's some sort of Node.js application. So we have this command line tool, Yle, which is like a binary through which the cloud is operated. It has this command Yle init Terraform, which asks for these basic questions like which namespace and some tags and the basic things about the application. I fill this out slowly, it seems, and then we want to create a load balancer for it, and we don't need any special DNS names, and we want it to be on the public internet. And this generates a set of Terraform configurations, nothing special about this, just a typical set of Terraform, and we can do some sort of environment-specific modifications, in this case just that there's only one pod running, so we can get it up and running quickly. Once we've done this, we can issue the Yle Terraform test apply, which takes a while because it runs inside a Docker container and does all sorts of things. It's like our version of TerraGrunt. Yes, but once it has done its thing, then it generates a typical Terraform plan, and you can see it creates all sorts of Kubernetes resources. And we say yes, and it starts generating those, and then we link the application with what we have is this called deploy file, which links the application to the infrastructure. And then give it a name, it refers to the repo, and then get a deploy file and modify it to refer to the actual demo API that we created here. And once it's done, and we save the file, we can observe that the Terraform run has gone through, and it currently runs some sort of sleep container, and we want to get the application to run our software. And we do it with the same tool. It lists the applications available, the versions available, and we select the newest one, and it starts deploying with this sort of nice ASCII graphics. You can also run it in CI/CD, but we can do it also this interactively. And it takes a while to roll out the new version of the image, and it has done, and then it prints out these metrics dashboards for this application. It's for hygienic reasons I've hidden them, but you can imagine me clicking those links and getting our Grafana instance showing these super basic metrics about the application. You can see the application logs if it has actually started, and some Kubernetes events and these basic metrics. And you can also drill down to the application logs more deeply if you want with the link. We have a Elastic Stack running for that. So if we are lucky, the DNS has propagated and the address for our application is already found in the internet. And we find the address and curl it, and voila, it's done, it's running. So that is the good parts, the easy parts. It's pretty easy to get a service up and running, which I think should be true of all IDPs, and probably is. We have Terraform and Kubernetes manifests. It's about 1,500 lines. Of course, some of it's conditional on some flags, and we also have some stuff inside the Yle tool, which is the command line interface. And we, of course, don't want everyone to handle all these manifests by hand for these hundreds of apps that we have. So the ugly, so the good, the ugly, and the bad. This was the better way to present these. And the worst thing is, I think, the API or the user interface. And this is the list of all the options, the parameters of our module. I'm not going to go through all of them, but as you can see, there's a whopping 72 variables. Some people might think that's a nice thing, that it supports many things, but I think it's a bad interface for the user. I think it's awful. You need help even to get started with these sorts of interfaces. So what we do is we provide a template. It might be some sort of copy-pasting systems. We have this Yle tool which can provide the basic configurations, but I think if you have to provide a template, it's more like a red flag for the whole system, for the usability of the system. And I feel like when you resort to these sort of systems, you have this templated golden path. It's like we're putting the user on a tightrope. Everything is fine if you go through this narrow path. If you step aside, all bets are off. Instead, we should just offer the options that the user understands and cares about. Does it mean that we don't offer every possible option? One could imagine one thing, and my answer is a resounding yes. That's exactly what it means. I think like like a guideline or lesson or advice. I think you should only provide a set of specific types of apps with very limited options. We could, for example, have some sort of a public application or some sort of API behind a proxy or something. And we should also provide a documentation how to create a completely custom application, which we currently do not have. The documentation is the implementation currently, so it's very difficult to do it otherwise. And the bad, then next. My feeling is that the bigger problem is this unclear division of responsibilities. There's the API part which the developer cares about. Then there should be this clear boundary between the API, the options, and the actual app module, whatever way you want to implement it. And this is the part that the ops team or the IDP team cares about. And at least in our environment, we still are interested in the stuff that is happening inside our clusters and in the cloud. The developers do care about that, even if they don't understand all of the nuance of that, but also, of course, the ops team cares about it. So we don't want to hide all that either. But the problem is that we leak these implementation details of the app module. Or you could say we spit them with a garden hose to their faces. So first is that the actual API already contains implementation details, like just the fact that it's a Terraform configuration, but even the variables, the options are implementation details partly. But let's say we want to do a change in the app module. We maybe half a year ago had to fine-tune the n-dots DNS config because we had problems with the performance of the DNS servers during high volume times. So we added this to the app module, and then this is pushed back to the users, and they run their Terraforms, whichever way they do it, and they get this sort of plan, and they are like, I don't know, what is this? It's the same as the changing the load balancer from internet facing to internal. I don't know what, does it break my service? I don't know. I just apply it. So these sort of implementation details go this round trip from the users back to the cloud, and they have to apply these changes that they don't understand or care about. What is said should be that these details should be encapsulated, or we say hidden. It's not that they are so secret that we can't show them, but the effect of the changes should be only affecting the insides of the app module, however it is implemented. So as a sort of a thought experiment or example, if you can imagine using some sort of a third-party payment processor, maybe you're already using one. It's the same situation. You have some sort of API, and then the payment processor has some sort of payment service, however they have implemented it. And imagine then that if the payment service sent you an email that we changed our internal implementation, you need to run some sort of a setup command again. This already would be like ridiculous. I don't know if anyone does this, but imagine next day they send another email saying that the setup call you made yesterday changed something in their systems, and that's why it stopped working for you. So it's your fault because you ran the setup call. Maybe it changed some sort of load balancer from public to internal or something. So my feeling is that we force the users of our IDP to apply changes they know or care nothing about in a similar way. So I think, as another guideline, I think you should develop your IDP as it were a service from a completely separate company. What would you tolerate from a separate company if you were using that? So in summary, I don't think I have proved, but my feeling is that these sort of bad APIs, they lead to one, poor user experience. There's so many options you can't even understand all of them. They lead to this sort of inefficiency on both sides, both the users of the platform and the developers. They cannot do their job independently from the users, and often they lead to more accidents also. Or in other case, this sort of fear or disinterest, which leads to drift, which leads to more accidents in the later. So what's the way forward then? My initial feeling when making these slides is that we do nothing, I guess. Because it's always easiest to just keep adding more stuff. If we have 72 options now, maybe tomorrow it's 73 options. But my feeling is that it doesn't seem to work. I think we all agree in our organization, even if we don't agree with the reasons. The operator pattern, which has been mentioned many times here already, seems tempting because it's a nice pattern. We could have some sort of Yle app operator, and we have these custom resource definitions. We could have different types of applications. They could be as fine-grained as we want, and the implementation details would be hidden from the developers. We could actually go as far as to implement it with the current app module inside the operator and then change the implementation inside under the hood without the developers noticing anything. That's the whole point of this encapsulation. But the fact is that this route is laborsome and requires a lot of engineering, and it requires people who can do this type of engineering. And this is where it comes to the scale of our operations. We are 7 people in my team. One is like a team leader, and we have other things to do. We are not just developing this platform, we are operating our systems, we are helping the developers with other things, and so on. So it has drawbacks, this route. But we're also investigating and making POCs, proof of concepts, for other tools that utilize the operator pattern smartly. Like, for example, Grow, which I guess is now being workshopped in the breakout room, or Score, or maybe Dapper, which was mentioned in the Mauricio's talk. But whatever the choice, I think it must support creating a good, tight interface which doesn't have any implementation details, and provide the ability to divide responsibilities so the users can do their job freely and we can do our platform stuff without harassing the users. But I just wanted to warn you that any new shiny tools will not solve all of your issues, because this is an engineering thing. If you get a new tool, you can still make the same mistakes with the tools. It's just easier to make them right. So, just a warning. So, that is all. Thank you.